So now let's study what is exactly logic gates. Now by definition, if you go through the definition, logic gates are defined as a digital circuit. A digital circuit that follows certain logical relationship between the input and the output voltage. If you put an input, there will be an output. Now, this input and output, there are different logics that you can use. Say, suppose if you're putting an input of 0, you may have an output of 1. So, if you are putting an output of 1, you may have an output of 0, or if you're putting an output of 1, you may have an output of 1. So, in a way, because of the arrangement of this digital circuit, we have certain logical relationship. There is a logical relationship between the input and the output. So, these are what are known as logic gates. And the first logic gate that you have is your NOT gate. NOT gate. Now, what is the logical relationship between the NOT gate? Now, before that, the NOT gate, if you look at the NOT gate, you will see that if 1 is your input, then the output will be just the opposite. If our input is 0, then the output will be 1. So this is the basic function of NOT gate. Now, this produces an inverted version of the input at its output. So inverted version of input. So if you look at the symbol, now even though you know the digital circuit and you know its relevant explanation or relevant logic, but still you have to know the symbol, because sometimes the name won't be given, only the symbol will be given. So if this is your input, if this is the input A and the output is Y, the symbol is given by, this is your diode symbol and a NOT in the tip of the diode. So this is the symbol of your NOT gate. And if you look at the truth table, if this is input and this is output, it is given by, if this is the input 0, then the output is 1. If the output is 1, then if the input is 1, then the output is 0. So this is the basic table of your NOT gate. Now let's have a discussion on what is OR gate. Now the speciality of OR gate is that it has 2 or more inputs and with only one output. So now the logical symbol is this. For OR gate, the logical symbol is like this. So if A and B is your input, then the output will be Y. So this is your output. Now the logical explanation is that OR goes with the plus symbol. In my previous example of NOT gate, what you can say is the output and input is if A equals to A bar. And the output is, for OR gate, is given by A plus B equals to Y. For NOT, this was your input, your output will be this one, that is A bar, that is the reciprocal. Now the reciprocal means either 1, then the bar will mean 0, the opposite one, either 1 or 0. But over here, if you look, say suppose you have put, now if you look at the truth table of OR, I'm just removing this part. If you look at OR, if you look at the truth table, this is A, this is B, and this is Y. Now this is 0. Say suppose this is 0 and B is 1. Now 0 plus 1 is 1. 1 plus 1 is also 1. 1 plus 0 is 1. 0 plus 0 is 0. So this is the basic definition of logic that you can use. Something that is nothing but there is still a positive voltage. So your output will be a positive voltage. So if there are two positive voltages over here, so your output will also be a positive voltage. Now if one voltage is present and the other voltage is absent, so you will still have a positive voltage. And in the last case, 0 and 0, no voltage, no voltage. So output will also have no voltage. And this is given by A plus B. So 0, 1, 1, 1, 0, 1, 1, 1, 1, 0, 0, 0. So this is its truth table. And this is how we can understand the logic of OR.